Okay, so today we're going to be working with rotations. Now, rotations, there are basic rules that you have to follow no matter what. I'm going to work basically just from the same one example. Our original point is going to be at 3, positive 2. This will be our original. So we'll call that point A. Point A is located at 3, 2. We'll have not A down here as a 90-degree clockwise rotation along the origin just being the center of your graph. So 90 degrees from here, you can kind of think of it as just taking this paper, or taking this board in this case, and turning it 90 degrees clockwise this way. If you have a physical piece of graph paper, you can actually do this and you will see where that new point is. Our new point is going to be at positive 2, negative 3. So I'm going to go ahead and write that. My new point is at positive 2, negative 3. It is not going to work the same way as a reflection would. A reflection, this point should be the same distance from this line, but that's not the case. Instead, my new point, A prime, is going to be at 2, negative 3. And there is a pattern that you'll see as we continue to rotate this. We're going to rotate point A now 180 degrees, counterclockwise or clockwise, about the origin. So that just means we're going to take our paper and turn it 180 degrees. There's 90 degrees, and there's 180. Except I just realized I turned it the wrong way, but I just can't be bothered to re-record this because it takes too much time. So 90 degrees going clockwise, this time for real. 90 degrees, 180 degrees. So now, holding our paper this way, we look at where our original point was, and we're now going to be at negative 3, negative 2 is where my new point's going to be. Negative 3, negative 2. So let me put this correct. Negative 3, negative 2. And this point we're going to call A double prime. And that's going to be located at negative 3, negative 2. Our last point is what's going to happen if you took our original point, A, and rotated it either 270 degrees clockwise, or the same thing if you rotated 90 degrees counterclockwise. So 90 degrees counterclockwise, A will end up here. It'll end up at negative 2, positive 3. And same thing if you rotated it 270 degrees clockwise, 90, 180, 270 degrees, A is still going to be at negative 2, positive 3. So negative 2, positive 3. This is A triple prime. And this is going to be located at negative 2, positive 3. You might be able to look at these values and already see the pattern. Essentially, our rules are going to boil down to the same basic concept. All right, had to pause the video because it would have been incredibly boring just watching me write all of this nonsense. For rotating clockwise, the general rule is for every 90 degrees, the x and y coordinates swap, and the new y coordinate has its value changed to either positive or negative, whatever it was not before. So for example, if I took point A and wanted to rotate it without the graph, and I wanted to rotate it 90 degrees to A prime, I'm going to switch the x and the y value. So I switch these two. It will now be 2 and 3. And I will apply the negative to the new second value, which would be the 3. So my new A prime, without using the graph, A prime would be located at this new value. It would be located at 2, negative 3. even without the graph. I can do the same for the other two as well. If I rotate 180 degrees clockwise, then what ends up happening is it will be flipping twice. So I will switch the 2 and the 3, but then I will switch the 2 and the 3 again. So my values are still going to be a 3 for my x value and a 2 for my y value. The difference is, this time, both of the values will have the negative applied to them. So a double prime is going to now be located at -3, -2. A triple prime is going to be flipped one more time from here. We're going to flip the x and the y value, only we're going to apply the negative to that x value, that flipped value. So now instead of it being a -3, it's going to become a +3. So my new value, a triple prime, will be located at -2, +3. There is one last rule, but it's somewhat self-explanatory. Down here at the bottom of the page, if a value is rotated 360 degrees, then there is absolutely no change. To rotate a graph 360 degrees would be to simply turn the paper all the way over once, and there would be no change there. Next, I'm going to talk to you about rotating counterclockwise. When you rotate counterclockwise, and we'll use a different example point for this, rotating counterclockwise, we will use the coordinates 1, 4. So +1, +4. We'll call this point B, point Bravo. And this will be at coordinates 1, 4. To rotate it 90 degrees counterclockwise, our new coordinate is going to be at -4, +1. So -4, +1. This will be B prime. That is at -4, +1. You can already see a pattern starting to emerge here. If we rotate it 180 degrees counterclockwise, 90, 180, we can see that our point will be at -1, -4. So we'll go ahead and plot that, -1, -4. I don't think it's going to show up on my camera. Barely. Let me move this up. So B double prime is at -1, -4. And B triple prime, which is what happens when we rotate 270 degrees counterclockwise, 90, 80, 270, we will be at 4, -1. So we plot it at +4, -1. And this will be B triple prime, and that is located, we said, at 4, -1. Let me go ahead and pause my recording while I write out those rules. If you want to pause it and see if you can determine the rule on yourself, that'd be cool too. All right, I also went ahead and switched which side the paper was on, just to add to some differentiation here. So the rotating counterclockwise, the definition of how to do it is almost exactly the same, with one key difference. The difference is that for every 90 degrees, the x and y values swap. That's the same. However, this time, it is the x value that is going to have its value swapped to either positive or negative. So for example, if we go from a value that is x, y, so +1, +4, we're going to switch the 4 and the 1. And that is going to now be 4, 1, but we have to take that first value, the x value, and make it negative. So it will become a -4, and the 1 will stay a positive. And we can verify that that is the case by looking at B prime. Same deal with 180 degrees as with the 180 degrees going clockwise. You are essentially taking your paper and flipping it upside down. The direction by which you flip your paper in that direction is irrelevant. 180 degrees is 180 degrees. You will keep the values in the same place. X and Y will not switch. However, both of them will be turned negative or positive. You will take the opposite values there. For B triple prime, this is 270 degrees counterclockwise. You might notice that this one could be considered the same as rotating 90 degrees clockwise by looking at this chart here. Those will give you the same value, which is that you will switch these two values, x and y will be reversed, and instead only the second value will be turned negative. So you will flip these. The 4 will remain a positive, it will be the first number then, but the 1, which will have become the second value, will be turned negative. The one piece of advice I have for you when you are rotating is keep some graph paper handy. It does not take very long at all to graph out a coordinate and double check your work, especially if we are taking a test or if there's a quiz. It's a lot better to get the information right the first time rather than racking your brain just staring at a chart. And that's it for the notes for rotating clockwise and counterclockwise. Yes, this paper will be making its way onto Canvas, and this graph will be staying here in this video.